In previous video, we learned tangent. In this right angle triangle, we have an angle theta. The ratio of opposite side to the adjacent side, we call that tangent. Now, if we take the ratio of the opposite side to the hypotenuse, we get another ratio, and we call that sine. So, sine theta is the ratio of the length of the opposite side of the angle theta to the length of hypotenuse. This is the symbol of sine. The sine of different angles, that is, the ratio of the opposite side to the hypotenuse of different angles, are different. For example, let's look at sine 30 degrees. Here is a right angle triangle with a 30 degrees angle. Sine is opposite over hypotenuse. If we measure the length of both sides and we plug in the numbers to get the ratio, we will get 1/2 or 0.5. This value of 0.5 is fixed. For all right angle triangle with 30 degrees, the opposite over the hypotenuse is always 0.5. How about sine 40 degrees? This is a triangle with 40 degrees. We take the opposite and divide by the hypotenuse, and we will get 0.6428, rounding off to 4 decimal places. And this is fixed. For all right angle triangles with 40 degrees, the opposite over the hypotenuse is always 0.6428. How about sine 50 degrees? The opposite over the hypotenuse is always 0.7660, rounding off to 4 decimal places. And this is fixed. For all right angle with 50 degrees, the opposite over the hypotenuse is always 0.7660. Just like the tangent, we do not have to memorize the value of 0.6428 or 0.7660. This day, we can find out the values from a calculator. For example, to find the value of sine 40 degrees, we just punch the following buttons in the calculator, and we will get the value of sine 40 degrees. Sine 40 equal . Let's look at a few questions where we are required to find the sine of an angle. We are not given the size of the angle, but we are given the length of the sides. Let's look at a few questions where we are required to find the sine of an angle. We are not told the size of the angle, but we are given the sides. Here is a triangle with angle theta, and we want to find sine theta. Sine theta is opposite of theta over the hypotenuse. So to find sine theta, we need to find the length of the opposite side and the length of hypotenuse. The side with 20 cm is the hypotenuse because it is opposite the right angle. We learned that in Pythagoras Theorem. So hypotenuse is 20. The opposite of theta is 12. So sine theta is 12/20, which is simplified to 3/5 or 0.6. Here we want to find sine theta as well. Sine theta is opposite over hypotenuse. The opposite of theta is 24. Hypotenuse is 25. So sine theta is 24 over 25, or 0.96. So is this one. We want to find sine theta. Sine theta is opposite over hypotenuse. The opposite of theta is AB, but we do not know the length of AB. Hypotenuse is square root 89. So sine theta is AB over square root of 89. Now we need to find the length of AB. For this, we need to make use of Pythagoras Theorem. The hypotenuse of this triangle is square root 89. Using Pythagoras Theorem, we have square root 89 square equal AB square plus 5 square. Square root of 89 square, we get back 89. And 5 square is 25. We move plus 25 over and it becomes minus 25. And then we get rid of the square of AB by taking square root of it. And we do that to the left hand side as well. And we get AB is equal to 8. We plug in this number into here. And we get 8 over square root 89, or 0.848.